Hi boys and girls, today we're going to go over Abby's arrays from Unit 6, Module 4. Let's take a look. Number 1, it says Abby is setting up an array to solve 1 3/4 times 2 1/2. Fill in the blanks on the array. So again, here is our expression, and so here's a blank right here, and several other places. I see a 1 right here, so if one whole is here, I know I'm splitting up 1 3/4 on this side, so 3/4 is going to come right there. 3/4. And then I know I need 2 1/2 multiplied, so I'm going to have 2 wholes right here and a half right there. And now time to fill in the inside. Right here I'm going to multiply 1 times 2 and write the product there. 1 times 2 is 2. So doing the same right here, 3/4 times 2, because I'm doing 3/4 times 2. 3/4 times 2 equals 6/4. And now I can also say that's equivalent to 1 2/4 or 1 1/2. Coming over here, 3/4 times, multiplying 3/4 times 1/2 equals 3/8. And then my last one, 1 times 1/2 equals 1/2. Now with all of my partial products here, 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 and here, I'm going to add it up. So I'm just going to write down the products here on these blanks. I have 2 wholes plus 1 1/2 plus 3/8 plus 1/2. I know to solve this, when I'm adding, subtracting fractions, I need to have common denominators. So looking, I have a 2, 8, and a 2 in the denominators. I know that I can make halves into eighths, and so that's what I'm going to do. I'm going to change this to 1, and how many eighths? Halves to eighths, I need to multiply by 4. So it'll be 4/8. I can also know what is half of 8. I know that's 4. So over here is 4/8. And then my 3/8 stays the same. And so does my 2 wholes. And so now I can add this together. I know that 4 plus 4 is 8. So actually that's another whole. When I combine this half and this half together, that's another whole plus 3/8. So I have 4 3/8 as the final answer. Number 2, Abby needs to solve 2 1/2 times 3 2/5. Sketch and label an array to show this. So we're basically going to now create what we just solved up top. So here is our array. I'm going to have 2 1/2 over here, and then 3 2/5 up top. Here in my first square, I'm going to write 6 because I know that 2 times 3 is 6. Next, 1/2 times 3 is what? That's right, 3/2, which is the same as 1 1/2. In my next box, 2 times 2/5 would be 4/5. And then lastly, 1/2 times 2/5 would be 2/10, which I know 2/10 is the same as 1/5 is correct. I need to follow directions. This says sketch and label an array, so that's what I did. I drew the array and I labeled it. Next it says use your sketch to solve the problem. So again, I'm going to write these partial products and the blanks: 6 4/5, 1 1/2, 1/5. So 6 4/5, 1 1/2, 1/5, Again, as I said above, when you're adding and subtracting fractions, you need common denominators. So I see fifths and halves. So it looks like my common denominator is going to be 10. But actually, if I look here at this problem, I already know that 4/5 plus 1/5 is 5/5, and that's one whole. So can't I just say 6 plus a whole plus another whole plus a half, which would be 6, 7, 8 and a half? Yes, I can. My answer is 8 1/2. For question number 3, we're going to use doubling and halving to fill in the blanks and solve the problems. 5 1/4 times 12. I see there's a 6 over here, which means 12 was divided in half, which means 5 1/4 is going to need to be doubled. Double 5 is 10. 1/4 doubled is 2/4, which is same as 1/2. That's why I'm going to write down 10 1/2. 10 1/2 times 6 is the same as 10 times 6, which is 60, plus a half of 6, which is 63. B, 16 times 3 1/2 equals 8 times blank. So it looks like from 16 to 8, it was halved, which means 3 1/2 will need to be doubled, which I know double 3 is 6, double 1/2 is 1 whole. So the answer here should be, that's right, 7. And I know 8 times 7 is 56. 36 times blank equals 18 times 9. So it looks like 36, well, let's go backwards. Let's say 18 was doubled, which means 9 will be halved, because it's always double, half, double, half. Half of 9 is 4 1/2. 18 times 9 is 162. 15 times 6 2/3 is the same as blank times 3 1/3. Well, I can see that 3 1/3 was doubled. That means this number here is halved to be 15. So what is double 15? That's right, 30. 30 times 3 1/3. So I know that 3 times 30 is 90, and 1/3 of 30 is 10. Therefore, this answer is 100. Let's go look at number 4. Number 4 says Adam made a birthday card for his sister. The rectangular card was 6 1/2 inches by 9 1/3 inches. What is the area of the birthday card? Make a labeled sketch to model and solve this problem. Show all your work. Let's go ahead and make that sketch. It's going to be 6 1/2. That's not a very good 6. Let's try that again. Let's do 6 1/2 by 9 1/3. 6 times 9 is 54. 1/2 9 is 9/2, which is the same as 4 1/2. 6 times 1/3 is 6/3, which is the same as 2 wholes. And 1/2 times 1/3 is 1/6. I know that I can change sixths into 12ths for common denominators. Let's go ahead and write down what I'm trying to add up. I'm adding 54 plus 2 plus 4 1/2 plus 1/6. I know that I can change halves into 12ths. This will be 4 6/12. And I can change 6 into 12ths. That will be 2/12. Again, remember the 2 and the 54 are still there and did not change. 54 plus 2 is 56. Plus 4 is 60. And then we have 8/12, which I know 8/12 is the same as 2/3. So my answer here, my sum is 60 2/3 square inches. And keep continuing on number 5. Convert these fractions to decimals. 8/10 is the same as 8/10 4/5. That'd be 8/10. 3/4, 75/100, and 6/5. 1 and 2/10. Number 6. Justin got a sack of jelly beans in 5 different colors. Half of them were red, 1/6 were green, 1/6 were yellow, 1/12 were orange, and 6 were black. How many of each color did he get, and how many jelly beans were there in all? So I like to draw pictures. I'm going to draw a picture. Let me kind of look at this. I'm going to say half of them were red. Now I'm going to color. Half of them are red. 1/6 were green. So I guess kind of the question is, how do you divide this into sixths? Because we have 6 and then we have 12ths. I can think about a clock. I know that 1/6 of an hour is 10 minutes. So I can make little tick marks. 5, 10, 15, 20, 25, 30. Didn't really space those out very evenly. So I can think 1/6 was green. 1/6 is the same as 10 minutes. So I'm going to say this part is green. And now 1/6 were yellow. So again, I'm going to go based upon thinking about these numbers as time. And I'm going to do 10 minutes. Again, my model is not drawn very accurately. Then I have 1/12 were orange. I don't think I have the color orange, so we're just going to shade this in black. 1/12 was orange, and that's the 5-minute mark. How many of each color did he get? And how many jelly beans were there in all? So looking back at the model that I drew here, I see that I have this little sliver left, and I know that it's 5 minutes, which 5 minutes is the same as 1/12. So this 1/12 must be the black section, and so I see that there was 6 in the black section, which means that 1/12 of the total amount was 6. So we have 6 here, 6 here. Here we have 2 5-minute sections, so this should be 12. And this here would be 5. What does it look like? Oh, never mind, it'd be 12, as well as the last one, yellow. And then red, we can add all those together, or it's also 6 times 6, which is the same as 36. Let's add all of those up. If we stack 36, now I know if 1/2 is 36 and the other half is 36, so I can add them both together, or I also know I can multiply 36 times 2 is 12, carry the 1, 72. So that's 72 total jelly beans. 6 of them are black, 6 of them are orange, 12 of them are yellow, and 12 of them are green. There's 36 red and 72 jelly beans in total. And that's all for today.